let's talk about categorizing numbers. Now, we talked about in class that up to this point, all of the numbers that you've ever dealt with in your math career fall into the category of real numbers. Real numbers. There is another category of numbers called imaginary numbers, which you're not going to have to worry about for a long time till you get in high school or college. But we will be talking about two different subcategories within the real number category. So you have real numbers, and then underneath real numbers you have two additional categories called rational and irrational numbers. Now if you look at those two words, you're going to see that there's a small word in each one of them that is the same. So we have the word ratio here, and we have it again right there. Rational numbers or ratio-null numbers are numbers that can be written as a ratio. And if you remember, a ratio was something that was written as a fraction. So you might have 3 people with blue pants to 5 people with black pants, right? So we'd write that as a fraction. We could also write it like this, or we could write it like this. But most of the time, we were concerned with writing it as a fraction. So rational numbers are any numbers that can be written as a fraction, whether it be a fraction like this, a proper fraction, or an improper fraction, or a mixed number, right? You can have any of those things. Anything that can be written as a fraction is a rational number. Anything that can't be written as a fraction is an irrational or not rational number. So let's look within the rational numbers and talk about the different categories. Now, the innermost category, the most specific category, is natural numbers. Natural numbers are all the numbers between 1 and infinity that you can count on your fingers and toes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I could borrow other people's fingers, I could count up to infinity, right? So I can count as high as I want, but they have to be numbers like 1, 2, 3, and 4. They can't be 1 1/2, or 1 1/3, or 2/3. Natural numbers don't include fractions or decimals. So all the numbers that you can count on your fingers between 1 and infinity. Whole numbers are almost exactly the same, except that whole numbers are all the natural numbers, so all of these, plus the number 0. So whole numbers include the number 0, so they would be all the numbers between 0 and infinity that are counting numbers. So 1, 2, 3, 4, 5, not 1 1/2, 2 1/2. So let's think of some examples of some natural numbers. We might have, well, obviously we have 1 because it starts there. Might have 1065, right? We might also have something that's written like this. What if we wrote 45/9? Is that a natural number? Well, yeah, because 45 divided by 9 is 5. It can be written as a fraction, so we know it's rational, but 45 divided by 9 gives you 5, which is a number you can count to, and it's between 1 and infinity. In whole numbers, we also have those same numbers. We have 1, and we might have 1065, right? 1065 would also fit in that category. We could also have 45 divided by 9, right, because that's 5. We also have 0 over here to the side, so we can have 0 within our whole numbers. Then that brings us to integers. Now, integers contain, if you can see this, they contain the natural numbers and the whole numbers, and they add some additional numbers. So the integers are all of the whole numbers. Remember that whole numbers include the natural numbers. So integers are all of the whole numbers and their opposites. So what we wind up with in integers is all the numbers between negative infinity through 0 and all the positive numbers through infinity. So think about what that means. So we could have any number between 0 and infinity and its opposite. So we might have an integer of 5. 5 is an integer. It's a whole number. We also have its opposite, negative 5. Those are also integers. 1065, right? We can also have negative 1065. 45/9, we can have that. 45/9, that is an integer. So is negative 45/9. And of course, we can also have 0, right? So then that brings us to the final category, which is just the rational numbers, right? So rational numbers includes integers, whole numbers, and natural numbers, and it adds all the other numbers that can be written as fractions. So then we're talking about regular fractions, the fractions that we think of as proper fractions, like 3/4, Also, improper fractions like 10/5. Also, mixed numbers, 1 and 2/3. All those are rational numbers. They're not integers because they're not counting numbers. They're fractions. It also includes all the decimals. So we could have 1.3 or 0.6. It also includes the repeating decimals. So something like 0.3 repeating is included in there as well. So we have terminating decimals, which means they end, right? So they don't have any other numbers. We also have repeating decimals. Remember, 0.3 with a bar over it is just 0.3333 on into infinity. Now, those are all the rational numbers. The irrational numbers are numbers that cannot be written as ratios, and that really just boils down to two different kinds of numbers. One, the only one that you're going to have to deal with is constants, but you're only going to have to deal with one constant, really, and that is pi, right? So pi is a constant. And it is a non-terminating, so irrational numbers are non-terminating, which means they never end, non-terminating. And then also they are non-repeating. So any number that is both non-terminating and non-repeating is an irrational number. Pi, if you'll remember, is 3.14159 and on and on and on forever. It's non-terminating. It goes on forever. It's also non-repeating. You'll notice there's no repeating pattern. Sometimes a digit might repeat. You'll probably get 4 again at some point, but it's not going to be a repeating pattern. Pi is one of them, special constants. Another kind of number that gives us non-terminating, non-repeating decimals is imperfect or non-perfect squares. Okay? Non-perfect squares. Now, just to refresh your memory, remember what square roots were, right? Square roots were 4, and the square root of 4 is 2, right? So because 2 times 2 is 4, the square root of 4 is equal to 2. The square root of 9 was equal to 3, right? Because 3 times 3 is 9. Square root of 16 was equal to 4 because 4 times 4 is 16. 16 is a perfect square because 4 times 4 gives you 16, and the square root of 16 is an integer, right? It's a counting number. Now imagine for just a moment we wanted to find, we know the square root of 4 is 2. We know that the square root of 9, we know the square root of 4 is 2. We know that the square root of 9 is 3. What if we wanted to know the square root of, let's see, 5? What would the square root of 5 be? Well, the square root of 4 is 2. And the square root of 9 is 3. Square root of 5 has to be somewhere in between there. Well, that means it has to be some sort of a decimal. And in fact, any non-perfect square, see 5 is a non-perfect square, it doesn't give me an integer. Any non-perfect square is going to give me an irrational number. The square root of 5, if you punch it into your calculator, give me a moment, I'll punch it into my calculator right now. The square root of 5 is going to be this. If you want to see it there, 2.23, blah, 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 blah. And it goes on and on forever. The calculator truncates it because it can only do so much. But that number will go on and on forever. And that's going to be any imperfect square that you get. So something like the square root of 17 would be one. The square root of 37 is going to be one. So imperfect squares and pi are really the ones that we have to worry about for irrational numbers. Okay? And that's really it. So thanks a lot.